Okay, graph 2 complete cycles of each graph, label all the critical points, identify the domain and range of each graph. Okay, so if we're going to make 2 cycles, we actually need to make 9 critical points. Okay, because we've got, it would be 8, but we've got a beginning and an end, so that makes an extra one. Okay, so looking at this, it's a lot more complicated than the last one we worked, but it's not that bad. So when we look at it, let's pick out what we see and what we recognize. Okay, so the 3 here, we're adding a 3 to this entire trig function. So that's going to be up 3. All right, let's just write it down and then we'll see what it does in a minute. We have plus 5, so we don't have a reflection to deal with this plus 5. If it had been minus 5, we would. But plus 5 means the amplitude is 5. Okay, 2/3 here. This is my B value. So remember, this tells us what the period should be. Now we're in degrees, so I need to do 360 divided by 2/3. Okay, and so that's going to give me 540 degrees. And to find how far apart my critical point should be, I'm going to divide 540 by 4. So my critical points are going to be 540 divided by 4, which is 135 degrees apart. And then the last thing is minus 150, and that is to the right 150 degrees. Okay, so let's go ahead and draw. I'm going to see if I can make these lines as straight as possible. Here we go. Alright, so I'm going to draw my tick marks. So first thing is, if the graph is being moved up 3, so is the sinusoidal axis. So we want to mark that one first. Oh, my pen's not going to want to do that. That's okay. So from my 3, you could almost draw a little. This is going to help. I don't think you need to do this on every problem, but definitely in the beginning. This is going to make everything a lot easier. Okay, so now let's think about how far above and below the sinusoidal axis we're going to go. That's what our amplitude is. So if I go 5 below it, all right, that's going to bring me right down here to -2. If I go 5, it's not wanting to. I got to change my pen. Hold on. It's going to be -2. And if I go 5 above it, that's going to put me at 8. And so I can already tell that the range of my graph is going to be from -2 to 8. All right, now let's think about the tick marks, our critical points, where they're going to be. Now I know they're going to be 135 degrees apart, but that doesn't mean I start at 0, go to 135, because I'm being shifted to the right 150. So that's the first one that I need to draw. So I go to the right 150, and then every 135 degrees to the right and to the left are going to be my tick marks. And starting now, we're going to get used to going to the left as well. So if I subtract 135, I'm at 15 degrees. If I subtract 135 again, I'm at -120 degrees. So I have 3. Remember we said we need to plot 9. So let's go ahead and go 4, 5, 6, 7, 8, 9. And let's add 135. This would be 285. This would be 420. 555. 690. Adding 135 each time. 825. And 960. Okay, so that's the setup. If you remember what I said before, that is the hardest part. The hardest part is getting your tick marks right. The only other thing you really got to watch out for is where to place that first point. And that's where whether this is cosine or sine comes into play. Because notice I haven't even talked about whether it's cosine or sine. The rest of the stuff, same. Now we look at cosine. We say, okay, parent function of cosine starts at a peak. It starts at a high point. And that used to be at 0. But now, since we've moved to the right 150, it's at 150. So 150 degrees. I should be at my high point, which is 8, and you should be able to plug in 150, and this should all work out, okay? Because what will happen is you'll get 0. Cosine of 0 is 1. 1 times 5 is 5, and then you add your 3 and you get 8. You don't really have to go through that all the time, though. Alright, to the right and left of this peak are going to be midpoints. Okay, and I'm just going to follow the pattern. And when I say follow the pattern, I mean it goes from the mid to the high or to the low, depending on which direction you're going, back to the mid, and it should look like a wave when you're done with the problem. You shouldn't have two mids right next to each other. And if you've plotted 9 points exactly, you should end up exactly where you started, because that's 2 complete cycles. And I would say that your sine wave should be as equal, if not nicer than mine, since I'm drawing on an air slate. It's a lot easier to draw on paper than it is an air slate, so you should be able to get at least close to this level of neatness. Okay, domain, always with these, is going to be all real numbers. And range, we could have figured out our range from the very beginning. It's going to be -2 to 8. And these are brackets because it does start and stop at those y values. Okay, let's do the next one. Alright, so back to finding out all the information. -5, that's a down 5. 6, that's my amplitude. Okay, we're in radians now, so when I find the period, I need to do 2 pi over 5. Okay, here the pi's are going to cancel and this becomes 10. So if I divide 10 by 4, I get 2.5. Okay, and I'm going to go ahead and use the decimal here. If I was dealing with pi, if the pi's had not canceled, I might want to use a fraction. That might make the dealing with pi's easier, and you could deal with the fraction 5/2 here. There's nothing wrong with that. And then lastly, we have our -2, which is a shift to the right too. Okay, so again, let's see if I can draw some straight lines here to start off. And since I'm going to be going down 5, I'm going to go ahead and make my x-axis kind of high up. Alright, so down 5. That would be about right here. You get to decide that. Amplitude is 6. That's telling me how high above and how far below I need to go. So you just add and subtract 6. And again, this is my sinusoidal axis, the down 5. It's not on the x-axis anymore. This is going to help you know where to plot all your midpoints, or your middle points. Alright, now we need to plot our horizontal tick marks. Since I'm moving to the right too, that's the one I need to plot first. All the other tick marks are going to be 2.5 apart. So if I subtract 2.5, I get right here at -0.5. If I subtract 2.5 again, I'm at -3. You don't have to go to the left again, but I had room, so I thought I might do that. So 4, 5, 6, 7, 8, 9. You want to make sure you get 9 tick marks in. So here we have 4.5, next would be 7, then 9.5, then 12, then 14.5, and then 17. Okay, now we need to plot our first point. This is a sine problem. So sine problems start like the parent function in the middle on the sinusoidal axis, right 2. So that's going to be my first point, and you can check it by plugging in a 2 in for x. And then a sine is going to increase next. Now your only exception to this is if instead of +6 this had been -6 and we would have had a reflection. Alright, and then you're going to go back down, you're going to go to your low point, and you're just going to follow the pattern. Once you get that first tick mark, you should know what to do from there. And again, you need to make your graph as neat as possible. Connect the dots. Domain, all real numbers. Range, -11 to 1. Alright. Going through the steps again. Pause this if you want to try this on your own. Go ahead, pause it, and then watch me, see if you got it right. So 3, that's going to be an up 3. Negative, that is right here. This is going to cause a vertical reflection. It doesn't mean it's going to change much of my information, but it is going to affect when I actually plot my first point. So make a note of it, but we're not going to write much down besides that for now. My amplitude is still 7. Okay. The period, since I'm in radians, I'm going to do 2 pi divided by my b, which is 2. So the period in this case is going to be pi. The critical points are going to be pi over 4. Don't have to simplify that. Units apart. And this x plus pi over 4 means I'm going to be moving to the left pi over 4. Alright, let's plot. Let's draw some lines. Since I'm up 3, let's mark that. That's now my sinusoidal axis. And I'm going to go up and down 7 for the amplitude. So I'm going to go up all the way to 10 since I add 7. If I subtract 7, I'm down here at -4. This is how high and how low my graph is going to get. So at this point you can go ahead and write down the range if you wanted to. Okay, the period is pi. Critical points are pi over 4 apart, and we have left pi over 4. So we start over here with left pi over 4. So that's going to put me at -pi over 4. Now if I add pi over 4, I actually land right on 0. This really doesn't happen too much on the more complicated problems. It didn't happen on the last 2 examples we did, but when it does happen, you need to make a note of it because you don't want to skip over it. Alright, and then pi over 4. And then just keep making your tick marks. Remember, you're going to have 9 total. 4, 5, 6, 7, 8, one more. So then this would be, add another pi over 4, you get pi over 2. And sometimes this can become pretty tedious, but in this particular case, these are values that we're used to on our unit circle. 3 pi over 4, 4 pi over 4 a pi, 5 pi over 4, 6 pi over 4, which would be 3 pi over 2, and 7 pi over 4. And I could have gone to the left one more and not had 7 pi over 4. It doesn't really matter as long as you have 9 total. Okay, remember how I said this is going to come into play when we plot our first point. This is a sine, but since it's vertically reflected, I need to make sure that I'm vertically reflecting from what the parent function would look like. Okay, so left pi over 4. Alright, we're over here. With sine, you start in the middle. I'm still going to vertically reflect it, but if I start in the middle and I vertically reflect it, still start in the middle. But instead of going up next, you're going to go down next. Then to the middle, then back up, then to the middle, down, middle, up, middle. Just a quick note, if this had been a cosine problem, instead of starting at the high point, you would start at the low point when you have a vertical reflection. With sine, you'd start in the same place, but your next point would be low instead of high. Take any of these points, plug it in for x, and that's how you can check your work. Again, domain, -infinity to infinity. Range here would be -4 to 10. Okay, number 4. We've got up 5. Oh, we got to write all. I'm going to make sure I go in red here. Stay consistent. So we've got up 5. We've got another vertical reflection. And this time we have it in cosine, so you'll see what I was talking about a second ago. This should be an L. We've got amplitude 2. Got a cosine. Okay, period is going to be in radians again, so I'm going to do 2 pi divided by 1/4. Notice that the pi's do not cancel in this case. We're left with 8 pi. That means our critical points are going to be 8 pi divided by 4, which is 2 pi across. And we're going to the right pi units. Hopefully these two will always give you the same. Either they'll both have pi or they both won't. Technically it doesn't have to be that way, but that's pretty much what you can expect. Let's draw our axes. I'm going to draw my x-axis low in this time since I know I'm going to be up higher. So up 5 would put me about right here, and my amplitude is 2, so I'd go up to 7, and I'd go down to 3. And go ahead and continue to draw in your sinusoidal axis. It'll help you figure out where your middle points are. This is not an asymptote though, it's just to kind of help see where you're at. Alright, the rest of my tick marks. Right pi. So right here I'm at pi. My critical points are 2 pi apart, so my next critical point is going to be at 3 pi. If I went to the left, I'd be at negative pi. Let's go to the left one more. That would put me at negative 3 pi. If I continued to the right, we'd get 5 pi, 7 pi, 9 pi, 11 pi. I think that's enough. 1, 2, 3, 4, 5, 6, 7, 8. One more. 13 pi. And when we go to plot that first point, remember, you're using the fact that cosine starts at a high point, just like the parent function, but with the vertical reflection. Okay, so at right pi, cosine would start up here at 7, but since I have a vertical reflection, I would put the point down here, and again, it's easy to check. You just plug in pi. Pi minus pi is 0. That'll change that whole thing to 0. This gives me a 1, and 5 minus 2 is 3, whereas 5 plus 2 would have been 7. Alright, so it's really easy to check. The nice thing about cosine is once you plot that first point, you're either at a high point or a low point. You got to go mid on both sides from there. And you follow the same pattern we've been following this whole time. Make sure it's periodic. Make sure you have 9 critical points. Toughest part is getting your hash marks or your tick marks right at the very beginning. Domain, all real numbers. Don't get that wrong on a quiz or a test, because that's pretty easy to remember. Range would be from 3 to 7. Okay, last example. Again, if you want to see if you can do this on your own, just pause the video and try it. Okay, down 12. Amplitude would be 20. No reflection to worry about this time. Cosine, we'll get to that when we're actually plotting the graph. I'm in degrees again. We haven't done one like this last couple times. So the period, remember in degrees, you're going to do 360 divided by 30, which is 12. And this is degrees, so this is a pretty small period. Okay, critical point is going to be 12 divided by 4, which is going to be 3 degrees, and left 4 degrees. Alright, so let's mark our lines, get our hash marks right. I want that to be straight. Okay, so down 12 would be about right here. And if my amplitude's 20, I'm going to go up 20, which would put me at 8, and down 20, which would put me at negative 32. So I already know what my range is going to be, negative 32 to 8. If you want to go ahead and write domain and range at the very beginning, that's fine. You don't have to graph it to even figure that part out. Okay, sinusoidal axis right here at negative 12, just there to help you know where your midpoints should be. Left 4 degrees, and critical points are 3 degrees apart. So I'm going to be right here at negative 4. If I add 3 to that, I'm at negative 1. If I add 3 to that, I'm at 2. You really should put your degrees simple. If I add 3 again, you just keep adding 3. 8, 11, 14, 17, 20. Okay, plotting that first point, really our last big challenge on this. Cosine, no vertical reflection though to deal with. So again, left 4, that tells us if it's sine, you start in the middle. If it's cosine, you start at the top. And then if you have a vertical reflection, you deal with it. Okay, make sure you're hitting all your tick marks. Two complete cycles.